Всім привіт! Мене звати Діма Малеєв, я інженірінг-менеджер в компанії Affirm, і я дуже радий, що ви прийшли сьогодні на наш онлайн-мітап. Сьогодні ранок, так що, вибачайте, можу трошки полутати слова, для мене ранок. І вітаю вас на нашому мітапі. Це перший івент після перезапуску AWS Ukraine. Ukraine. І, коротше, прикольно. Давайте, я зараз модерую цей івент на дивані. Напишіть, будь ласка, наш чат в Ютубі, як ви дивитесь цей івент, тому що от такі в нас зараз івенти, бо онлайн. І я вітаю вас на нашому івенті. Я сьогодні буду хостом до цього івенту. І сьогодні цю зустріч ми будемо посвячувати повністю .NET. Що таке AWS Ukraine? Це пір-ту-пір українське ком'юніті для обміну досвіду роботи з AWS про платформу, нові сервіси та інсайти. Коротше, всюди, де ми можемо посидіти, понити, як тяжко зараз щось робити або взнати щось нове. Детальний таймінг цього івенту ви зможете знайти в описі трансляції. Причому після кожної доповіді ми будемо проводити невеличку Q&A-секцію, де ви зможете поставити запитання спікерам. При цьому наш спікер буде вибирати краще запитання, яке йому сподобається, і ви навіть отримуєте невеличкий приз. Всі запитання ми будемо проводити в спеціальному сервісі для питань слайду, лінк на який ви зможете знайти в чаті. Задавайте, голосуйте запитання, краще запитання я буду задавати, і спікер вибере краще запитання, яке найбільш сподобалось йому, і ви отримаєте подарунок від Eks, який є співорганізатором цього івенту, до речі, дякую, Eks. І це термочашка, пляшка для води та екосумка. Все, що вам зараз потрібно вдома під час локдауну. Знову ж таки, лінк на всі слайди запитання будуть у нас в чаті. І зараз я хотів би надати слово співорганізатору івента, компанії з великою експертизою в .NET і Advanced Consulting Partner Amazon Web Service, компанія NX. Запрошую на цей віртуальний стейдж Ореста Фургалу, Head of Partnership в NX. Орест, тобі слово.
Всім привіт, Діма, дякую за інтро. Як ви бачите по таймінгу, маю 3 хвилини на піч компанії, тому відразу до діла. Але знаєте, з чого хочу почати? Хочу почати з того, чому я працюю в цій компанії. Перше, тому що тут працюють кльові, цікаві люди. Друге, бо це українська компанія. А третє, це те, що компанія активно росте, розвивається, і тут постійно з'являються якісь нові можливості. От як ви подивитесь на цей графік, приєднався я в компанію 5 років тому, у нас було 450 людей. Зараз вже 1400. Це дуже хороший темп, який ми тримаємо попри кризу і попри всі обставини, які в нас зараз є. Як ми ростемо, як ми працюємо зараз? На карті ви бачите наші локації. Тобто тут є офіси NX, тут є NX-хаби, є міста, в яких працюють віддалені наші працівники. Тобто NX активно наймає віддалених працівників, і в тих місцях, де є більша концентрація таких людей, які працюють на NX віддалено, з'являються хаби. Такий хаб, наприклад, вже є в Івано-Франківську, в Вінниці, в Харкові, в Дніпрі. І оцю модель співпраці з компанією кожен з ніксівців може вибирати для себе сам. Тобто в нас є повністю ті, хто хочуть бути office-based, є ті, хто вибирають такий гнучкий режим роботи трошки в офісі, трошки з дому, і повністю віддалений режим роботи. І таким чином компанія виросла, і це підтверджується багатьма рейтингами. Тут ви бачите купу логотипів цих рейтингів. З них я хочу виділити Forbes, визнання нас в списку 50 найкращих роботодавців в Україні, ну і любий Developer.org.ua, рейтинг, в якому ми здобули 4-те місце. Безпосередньо моя робота стосується розвитку партнерств компанії, і AWS є нашим стратегічним партнером. Ми приєдналися до програми партнерства з AWS не так давно, і за рік ми досягнули Advanced рівня. Що це таке? Це рівень, на якому є всього-навсього 9 компаній в Україні з таким рівнем, і приблизно це там всього лише топ-13% всіх партнерів AWS. Наша експертиза у AWS підтверджується сертифікаціями та акредитаціями наших людей. Вже понад 100 людей є сертифіковано, і компанія дійсно підтримує ваше бажання сертифікуватись, здобувати нові знання. Як це робиться? Перше, вартість сертифікації повністю 100% компенсовується. Друге, в нас є навчальні матеріали зібрані. Третє, це є навчальні групи, які об'єднують людей, які разом готуються до цієї сертифікації, і це там з власного досвіду скажу, тримає в тонусі. Бо ти бачиш, що люди вже там частину матеріалу пройшли, а ти трошки відстаєш. Значить, треба підтримувати цей темп. І так готуватись до цих всіх сертифікацій є значно легше. Але сьогодні основна тема – це .NET Community. .NET Community в NX об'єднує вже понад 150 експертів, є більше 30 проєктів, на яких використовується .NET, і, що немало важливо, є 40 відкритих .NET Opportunities, .NET вакансій, і є .NET Hiring Week, який в нас зараз стартанув. Проекти, на яких .NET і AWS поєднуються, а також не тільки з AWS, це є дійсно класні клієнти. От декілька логотипів, які ви бачите, зверну увагу на два. Перший – це TuneIn, це величезна аудіострімінгова платформа, в якої 75 мільйонів користувачів. Кілька фінтех-компаній, але також цікавим є Fluke. Fluke – це компанія, яка не до кінця відома в Україні, але в вузьких колах вона відома. Коли куму електрику я сказав, що ми працюємо з Fluke, він каже, слухай, Fluke – це ці електронні вимірювальні пристрої, це як Тесла серед автомобілів. І це справді круті продукти, які використовуються досить широко. І про автомобілі ще скажу, що один з проєктів на .NET в нас – це компанія, яка є найбільшим продавцем машин класу люкс, я маю на увазі Ferrari, Jaguar, Bugatti та інших, яка працює в Великобританії. Ну, але про ці .NET вакансії і проекти ви можете дізнатись вже спілкуючись з нашими рекрутерами, і пізніше в ході цього .NET Hiring Week. От. А далі давайте до самої суті, до нашого мітапу. Дякую.
Господи, я побачив, що коли я працював на компанії NX, там було тільки 150 людей. 2013. Дякую, Орес, за такий краткий екскурс. І зараз ми переходимо до доповіді. І перша наша доповідь від Мартіна Бібі. Я переключаюсь на англійську мову, тому що наступна доповідь англійською. So, our event will be opened by the Keynote Principal Developer Advocate at Amazon Web Services, Martin Beeby. Martin, I'm sorry if I mispronounce your last name. Martin has been developing applications since he was 16 and over the past 20 years has worked on projects with many major companies and brands. His primary focus is on .NET applications and has worked as a C# and Visual Basic developer since 2001. Oh, I can feel your pain with Visual Basic, by the way. Martin will tell us more about .NET apps and deploy to Kubernetes. We will learn how to run containerized Windows and .NET applications in production on AWS. Martin also will demonstrate the benefits of running .NET Core Linux containers serverlessly with AWS Fargate. Moreover, we will cover core concepts and use demos to help you feel comfortable getting started with building and deploying .NET containerized applications on AWS. Martin, the stage is yours.
Wonderful. What a wonderful introduction. You got my name correct, by the way. Beeby is exactly how my name is meant to be pronounced. So that's wonderful.
Oh, great.
Yeah, exactly. It's not always the case. Sometimes it gets mispronounced a lot in letters as beefy, which is a very different word. But so thank you very much for having me. It's wonderful to kind of join and do this. This is 5 p.m. my time, so I think just an hour or two ahead. But it's a great way to start the evening. Looking really forward to it. I don't know how old you are, which are the people that are watching, perhaps, but I know that my applications, the kinds of I've been building since the Amiga days, the Commodore Amiga days, and so there is a slight Commodore Amiga theme to this whole talk today, which I hope some of you will appreciate. I have been a .NET developer for a very long time. I used to be previously a Visual Basic .NET developer, then a C# developer. I worked at Microsoft for 8 years as a C# developer, really. and I joined AWS around 2 years ago. Hopefully you can see my screen. At the moment, I see myself repeated again, but let's see if we can get that picture over to my screen. There we go. That's the stuff. So this is my slides. And today we're going to be talking about containerizing .NET apps and deploy to Kubernetes. I'm Martin Beeby, the Beebs on Twitter. If you are on Twitter, then @thebeebs is my name. And today we're going to be talking, starting with a little story around this guy. This is Guybrush, and he is a cloud consultant, a developer which goes from customer to customer, fixing their woes, fixing their problems. I'm sure many of you are either consultants or developers which basically do what he does, which is fix the kinds of problems that other people don't want to fix, or help people which have got problems and to overcome them. And Guybrush is off to see his very first customer of the day, which is Grog Computing. They're a small little startup on this island, on Melee Island. They are their board consists of a CEO, a CTO, and a VP of engineering at Grog Computing. And they are the official technology provider of a thing called the Pirate Festival. Now, these three gentlemen, the CTO explains to Guybrush that we provide voting systems for the Pirate Awards, and it keeps crashing. And this is quite a common problem. You know, you build a website, you build a system, but it keeps on going down. Especially in the .NET world, when maybe the applications were not built for the scale that they currently face today. The CEO says if the voting system is unreliable under scale, we will lose our contract for future pirate festivals. And the VP of engineering's got one clear ask and one real pain point, which is we need to make the system easier to scale and more reliable. Now, Guybrush does what any good consultant will do, and he tries to get the lay of the land, the understanding of what they're currently building and what their current setup is like. So he asks to see the data center, or where do you host this application? And they say, well, the data center's through the door. And he looks through that door, and there in the corner of the room is a man which has probably been developing .NET for as long as I have, hugging his machine. Was that 486? I don't know, which is what he lovingly runs the web application on. No wonder they have some problems here scaling their application. And so Guybrush says we've got 3 steps to kind of improve the reliability of your application. Now, step 1 is going to be that we are going to containerize our application. We're going to take our .NET application and we're going to put it into a container. And the reason for that is so that we can then move that container to the cloud and then use one of the many different AWS orchestrators to manage those clusters, to manage those containers in the cloud. And the reason what we're doing this, the third reason, the whole point of this is just to improve reliability. There's lots of reasons why you would use containers. There's lots of reasons why people are very, keen to start using containers and serverless as well. But one of the key benefits that you will find is just the pure reliability of building something in a container and then being able to shift that thing around, and it will work wherever it works. It won't change. It won't only work on your machine. It will work everywhere in the same predictable kind of way. And it gives you the ability to very easily scale up your application. Now, we're not going to re-architect the application into, make it very different. We're basically going to take what we currently have, put it into containers, and run it on AWS. And that's one approach, a simple approach to get us moving. But it's also one of the easiest approaches. And there's a few tools that are going to help us in this journey. Now, Guybrush says, look, to get started with this, I'm going to have to meet your dev team. So he goes and meets the dev team to containerize his application. And this is the dev team. They're working pretty hard, working on the latest and greatest features of this application. And he says, asks the dev team a little bit about what the kind of application they're building. Now, I don't know if you have these sorts of applications or you've worked on these sorts of applications before, but they're the kind of applications that are built by other people potentially, or they've been running for a very long time, and they're kind of fine and they kind of work, but they have this issue where, if something changes, like the scale or the demand on the application, then things happen. Memory leaks. There's a problem with a particular error which only occurs every other Thursday. There's issues with it. No one really understands it. No one really wants to spend too much time going to fix it. And people often inherit this. I've worked on projects like this. You kind of go in, it's someone else's code. It's not the nicest project to work on, but it's, we can do things to help here. And so the lead dev, she says, we have an ASP.NET application that's older than me. What can we do? Now, Guybrush is familiar with AWS and containerization. And he says, well, the first thing we're going to do is we're going to take a look at your application and we're going to put it into a container. Now, the next example is going to be the simplest possible way that you could do that. Inside of Visual Studio, you've got a .NET MVC application. This is actually a relatively new version of Grog and Dash, their application. Now, if you right-click the project, I've got some publish options, but no container options there at the moment. That's because there's no container element to my application. So I'm going to go in here and say add Docker support. I'm going to say add Linux Docker support, and it's going to create me a Docker file in my application, in the root of the application. Now, this Docker file, it's not important. We've seen Docker files probably before. What it does is it takes this base web application and it containerizes it. And now, because it's being containerized, Visual Studio is saying I could publish this to AWS. So I'm going to right-click it. I'm going to say I want to put this into Europe. I want to release it. I want to give it a tag, a specific tag for this container. Now, I could run it straight into a cluster, but what I'm going to do is publish it to the Amazon Elastic Container Registry. Now, this is a little bit like Docker Hub. The only difference really is that the Amazon Elastic Container Registry is private. So when you publish here, you're not exposing that container to the world, which you might do if you were using something like Docker Hub. We actually also have a Amazon Elastic Container Registry version, which is public. So you can create containers which can be shared with the general public. But by default, the base service is private. And most instances, that's probably the way that you want to do it. Now, we're doing a very straightforward thing here. We're publishing it directly from Visual Studio. In the real world, of course, we wouldn't do that. We'd be publishing it maybe to a CI/CD pipeline, which would ultimately maybe push it to take the code, build the application, put it into the Amazon Elastic Container Registry, and then some cluster or orchestrator would take that container and would start running your containers, running your application. Now, we're doing it directly from within Visual Studio. Now, the reason I have these AWS tools inside of Visual Studio is because I've installed the toolkit, the AWS Toolkit for Visual Studio. We have had support for Visual Studio for a very long time. So you can very easily, from within Visual Studio, build these sorts of containers using the toolkit, and also interact with lots of other AWS services as well. I'll also note here that we have toolkits for other development environments too. We have them for JetBrains Rider and for Visual Studio Code, the smaller editor. But this is the one which works in Visual Studio. And to be honest with you, it's the most complete version as well. It's the easiest way to get started with it. And so it has lots and lots of features. We're only touching on one of them, which is if your application has a Docker file in it, then that's enough for the toolkit to recognize it as a container-based application and then give you some options of what you could do with that container. You could directly publish it to a cluster, or what we're doing here is we're storing it inside of the Amazon Elastic Container Registry. Now, I'm taking an existing this is basically a .NET 5 application at the moment. But often these applications, they wouldn't have been migrated. No one might have worked on them at all. And in those instances, you might just have, you might not even have the source code. You might just have the application running in IIS. And for that, we actually have a tool called AWS App to Container. You can point this at you can basically take this and take a .NET application and put it into a container. We also have a porting assistant. We have a number of tools which allow you to, whatever situation your code is in, whether it's just installed on IIS and you just want to make a copy of that IIS and put it onto Internet Information Server, by the way, the web server. If you want to make a copy of that and put it onto and create a container from that, then we have a tool which can do that. We can take your existing source code, we can put that into a container for you. Or, we have the Visual Studio version, which I showed you a moment ago. So there's lots of ways to take your existing code, whatever the version of that it is, and put it onto AWS. Now, we can deal with Linux containers, or we can deal with Windows containers. It is more complicated when it starts looking at Windows containers, but everything I'm showing here is possible to do with Windows containers as well. So if you need to support a very legacy ASP.NET application, which is written in something, I don't know, web forms or something like that, and it's using the full version .NET framework, then you can absolutely containerize that with one of these tools and publish that as a container. It will get a little bit more complicated when we actually have to publish that, but we have support for Windows containers on the service I'm going to show you, EKS, today. So we'll put that aside for the moment. Whatever .NET application you have, however old it is, there is a way of getting it into a container and publishing it to AWS. So why is putting it into a container even a thing that we would want to do? What's more reliable? What's the point of that? And I'm just going to kind of show you a little bit with this little drawing. So if you imagine before, now I joked that gentleman had his application running in a kitchen on a single machine. But the reality is a lot of .NET customers that I speak to have a setup which is something like this. We have a user which goes through a load balancer, and then that gets load balanced to 1 sometimes, or 2 or more EC2 instances. And the problem with this in terms of reliability is if one of those particular machines has some kind of failure, I don't know, like there's a memory leak or something like that, and this particular machine, for whatever, the memory gets hit and it goes down, we might have some automation which recognizes the health of that EC2 instance and starts it back up and says, restart that machine for us, which is great. But the problem is this is an EC2 instance. And so, I'm being really generous here. That EC2 instance running a Windows operating system, let's say that takes 3 minutes to start up. We might find that more likely to be like 20 minutes to start up. For that whole time where that machine's out, then this particular machine's handling all of the load. And that machine might suffer the same problem. It might have the same application problem here, which is a memory leak or whatever, and that also fails. And then before we know it, all of the instances are failing. And there could be reasons, many, many reasons why an EC2 instance fails. It could be the application. It could just be, a problem with, I don't know, the actual underlying hardware for all I know. There's a hard drive fails or something like that. Whatever it is, it takes a while for the instances to restart. And so you're basically running without some of the capacity for a longer period of time. What we have in the with containers is a similar situation. We have a load balancer, which the user's going through, and that load balancer goes into a cluster. Now, the cluster could be, this could be managed by Kubernetes. It could be managed by other services like ECS, Elastic Container Services. There's lots of different ways of running containers, but fundamentally, this cluster will route the incoming request to one of the containers that you have. And we might have a number of these containers. And this cluster is actually, I've drawn it as a big box, but it's actually made up of a number of EC2 instances. So you might have 3 or 4 or 5 EC2 instances running to make up a bigger cluster. And then you place your containers and the cluster will place them on the different machines. If a machine fails, the underlying cluster machine fails, then it gets replaced. But it's unlikely to be the same sorts of problems of like a memory leak in an application. In that instance, it would be, probably a hardware failure or something like that. But if your application is actually causing one of these containers to fail, like there's a memory leak or there's a problem or whatever, which is caused by an issue, and that container has to restart. In most instances, containers can restart in a few seconds because of just the way that they're packaged and the way that they work. And so you can be instantly back to full health with, adding another container to replace the one which died, in just 1 second. And we could even scale up. We could add more containers, as we feel fit. So we could add more and more to our cluster. We could even make the cluster bigger, so we could add more containers to it in real time. So there's lots of things that we can do. But fundamentally, the whole reason why you would go for something like this over this is just reliability. Reliability. It's more reliable. You can scale this, and if applications fails, well, it's just one of the little containers fails. No problem. We'll replace it. It'll take a few seconds, and we're back to full health before we know it. So now we need to think about, well, what are we going to run our containers on? We have a container somewhere in the cloud. So what are we going to now run our container on? So we go to our local AWS salesman. This would be me. This is me in the hat. Or our vendor. It could be any cloud computing vendor, Google or Azure or anyone. And they will explain to you, how you can run a container in their cloud. And one of the things I like a lot about containers is that all clouds support them. All hosts, they're very easy things to host. Once you have your application inside of a container, it makes it very portable. We're building today, the application which we're talking about is using Linux containers. It's .NET using a Linux container. That means that I can run that anywhere. It really doesn't matter to the host at all, the fact that it's .NET. It's Linux. It's a Linux container for all it cares. And that means that we'll be able to run it on any cloud platform, in any container orchestrator, anywhere we like. Things become a little bit more complicated if it's a Windows container, because we have very good support for Windows containers at AWS, but not every cloud platform does. We were the first to add Windows container support in the market, and it's not as common as Linux container support. So if you have to run old legacy .NET, full fat .NET framework applications in containers, you do have to look around. We will be able to support you at AWS, but you might find that other cloud platform providers don't support Windows containers. So there are many ways to do this on AWS, but we're going to be using Kubernetes throughout this. Now, the two main flavors, the two main ways on AWS that you run containers are ECS and EKS. The biggest difference is that ECS has been around for longer. I guess you would say it's proprietary in that AWS invented this technology, ECS, and it's mainly like the way that most people on AWS would have produced containerized applications in previous years. There was really only one option, which was ECS for a long time. Then an open source alternative became popular. There are many ways of orchestrating containers, but another one which was very popular was Kubernetes. So we at AWS offer both of those options. You can either use ECS, which is extraordinarily scalable, battle-hardened, a fantastic service for running containers. I really like it. I prefer it to Kubernetes, but that's purely out of a preference of the different engines. You choose your own adventure. You figure out which one's best for you. But for me, but fundamentally, they can do the same things now at AWS. You can run .NET Core, and by .NET Core, I obviously mean .NET 5 as well, on Linux. You can run .NET Core on Windows, so you could use .NET Core on Windows containers too. Or we could use .NET Framework on Windows in Windows containers on both ECS and EKS. So it doesn't really matter what kind of container you have. Both of those services are going to be able to run your containers for you. Now, for the rest of this, I'm going to just show you the Kubernetes service. But just be aware, there is another one. You might hear about it. Some customers find that quite confusing. Hopefully, you just recognize that there's two options. One is an open source option, which is EKS, the Kubernetes version. And then we have ECS, which is more proprietary. It's something which has been a longer history at AWS. But both are valid options. we have customers running at a huge scale on both of these platforms. So what is Kubernetes? It's a way to scale those containers. It's a way to organize and manage those containers. It's open source. It was originally built by Google. There's been lots of contributions from lots of other vendors, including AWS, to that open source project. But certainly Google, it came from Google and the way that they manage Google services. You'll hear that the term, and I've used it already in this presentation, of container orchestrator. Like, it's an orchestrator. It takes your containers and orchestrates them. And basically, what we do is we, in code, define what our cluster should look like, define what containers we want to run, define what load balancers we have. We define that all in a file. We tell Kubernetes, look, this is what we want, this is what we want, this is what we want to run. And then it uses that file to then build and manage our cluster to our specification. And if we want to change the specification, we can just go in, make a change to change the different containers that are being used, the number of containers, all the different things we can do all through using the Kubernetes service. Now, you're going to, when you start looking at Kubernetes, you'll see some terminology. And I just want to cover some of that terminology and explain what it's meant by that. You'll hear the word a node. Now, I've mentioned a cluster before. A cluster is a collection of nodes. So in the example I'm going to show, we're going to have 3 nodes in our cluster. And that means underpinning all of the Kubernetes service for us is going to be 3 machines, 3 EC2 machines. And those are each nodes in my cluster. From an application point of view, you don't really need to know about the nodes. You just need to know you're just deploying your application. But from a physical creating the cluster, you will have to choose how many nodes you want in your cluster, and that's going to impact the cost of your Kubernetes cluster. Now, we would, a base recommendation would be in AWS have 3 nodes. That's generally because we have in most regions in AWS, we have a thing called availability zones. They are sort of discrete areas of a region. We basically would put or recommend you putting a node in each one of those availability zones. So you would say, I want 3 nodes to make up my cluster. They would each exist inside of a different availability zone. And what that means is an availability zone in AWS is like a separate building. It might be more than one building, an availability zone, but it's a separate building, which is a reasonable distance away from, a meaningful distance away from the other availability zone. So it's far enough away that if there was a natural disaster on one of them, it would take out one availability zone, but it wouldn't take out the other availability zone. But it's close enough that there's not huge latency between the two availability zones. Now, most regions, I think all regions in AWS, have at least 3 availability zones that make up a region. So we're quite unique in that sense. Other cloud vendors have similar setups, but if you're interested, look more into the availability zones and regions. It's a different concept. Now, we put one of those nodes in each availability zone, and it works. And that means that if one of your nodes fell over because of an availability zone failure, then the other nodes in the region would still be live. And so that's why you'll see 3 as the common number, which we would have nodes in a cluster. You think of a pod in Kubernetes as a set of containers that make up a single microservice. So you might have 3 containers, and they would belong inside of a pod. And so it's like, in this, we're going to have basically our application that's going to be our single application is going to be in a pod, and that's going to maybe have 3 or 6 replicas, or however many it's going to have. And a cluster, I've already mentioned this. It's like a cluster is what we deal with when we're connecting to Kubernetes. We're speaking to the cluster, but it's made up of these machines. Physically, the way that it looks to our application as one big cluster that we can just throw our application into. But in reality, it's made up of a number of different nodes. Now, there's lots of different hard ways to create clusters, and you can do it yourself. You can build your own Kubernetes cluster on a Raspberry Pi. You can follow documentation on the internet about how to do it. It's hard to do it from scratch. The easiest way is to go to your local cloud provider, like AWS, and use our managed service. So we have the Elastic Container Service for Kubernetes, or Amazon EKS. It's a fully managed Kubernetes control plane, we call it. And what it means is that we can create a new cluster using this service, and then we can start interacting with that service. So the way that we maybe create a cluster is we give our cluster a name. We're going to call it Grog and Dash. That's our application name. We set up some things like networking and subnets and blah, 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 blah. We choose the number of nodes that we want in our cluster. There's lots of things that we have to do to set up, but fundamentally it's just a wizard or command line interface to create our cluster. Once our cluster has been created, we can then connect to it using any regular Kubernetes tools. So there's one called kubectl, which is a command line tool that allows us to do stuff with Kubernetes. This is me connecting to my Kubernetes cluster. So AWS EKS, I give it the region name. I say update kubeconfig and give the name of the cluster. And what that does is it goes into my AWS account and it gets the configuration to then configure kubectl. So once that's done, that line of code's done, whenever I use kubectl now in the command line, I'll be connecting to that particular cluster. So now I can say kubectl get SVC or get services in my cluster. And you'll see that currently there's one service there in my application. Ooh. So I have got 3 nodes in my cluster, and I can inspect that by using kubectl. I can say kubectl get nodes at the top there, and it says, look, there's 3 nodes. There's 3 physical machines, and they are 3 physical EC2 machines that you will be able to see in your EC2 console if you wanted to see them. You can then start actually adding your application to that cluster. Now, kubectl has this function called apply, and there's lots of ways that we can interact with our cluster, but we're just going to apply a file. Now, a file is a description, basically, of how I want to construct my application. And so the file can either be in JSON or YAML, and it could even be a URL, which points to a JSON or YAML file. And so there is an example by Google. It's called a guest book. You can literally do kubectl apply file and then put past the, excuse me, too much Diet Coke. I really apologize for that. You can apply a GitHub. This is a direct link to the Kubernetes examples from Google, and it's a guest book application. So I basically call that file, and in that file is all the description of the containers and the Redis and all of the different services that I need to run my guest book. And then I can say kubectl get services, and it will show that I've got now a little app called guest book there, and there's a load balancer, which is used as a load balancer for my application. That's going to have created a load balancer in AWS, which we can go to, and then that will go into our app book, our guest book application. So now if I go to the load balancers URL, I actually have a guest book application that I can add. This simple sample, which comes from Google, is just a way of like adding who was there at that website. So you just type the name in and it stores the information in Redis. It's very straightforward, very simple. But you'll see that like that description file, that contained what containers to use, like the guest book application. It used containers for Redis, which is an in-memory store, and it put it all in my cluster. It's all running in my application, and then it created a load balancer so that I could get at that application. We can also go kubectl proxy, and what will happen is that we're able to get the dashboard for Kubernetes, so we can see a visual guide of all the things that are running our Kubernetes cluster. So in this grog, I've created my cluster already, and I want to create basically this application, which is a load balancer, 6 containers, and some Redis, which does the management of my application. This is what the YAML is going to look like, and I'm not going to spend too much time looking at. This is how you would define a load balancer in YAML for Kubernetes. So if I put this in a file and then said apply-f and then pass this file over to it, then that would go and create a load balancer for me. And that load balancer would be, as you see at the bottom, it's got a selector. It's going to go and select the grog and dash app on the front end tier. So that would go and create this piece of infrastructure for me. And then I could add to that existing file and say, okay, I want to have 6 containers from this image, the Beeb's grog and dash latest. And I want 6 of those. It's called grog and dash, and it's in the front end tier. And what will happen then, it will create 6 of those containers inside of my cluster. Because the load balancer was pointing to the app grog and dash, then it's actually the load balancer is going to point at those clusters as well. So it would load balance between the 6 containers. And now all of a sudden my application is basically coming alive. I've got my front-end .NET application. I've got my load balancer there as well. Now, I'm not going to go through it all, but basically I can define my entire application in a YAML file. So this is the YAML file which defines that. And once I've applied it, I've created my containers, I've created the application. If I go back and modify that file and then apply it again, like I could change the number of replicas to 3 instead of 6, it will then update that. And then Kubernetes will say, oh, there's 6 containers there now. Let's remove 3 of them and put it down to 3. So you can, this is a way of modifying how many different things are working, different containers are running, or the orchestration or architecture of your application. Okay, so we've rebuilt the site on Kubernetes. We're now in the cloud. We could build this as part of a CI/CD pipeline. So when someone checks in that YAML file is then deployed to our cluster, and the cluster pulls the containers from our container registry and starts building our application. And it means that we don't have to think as a developer. We don't have to necessarily think about how we're going to run this application. We're just doing it all through the infrastructure as code through Kubernetes. Our build system is going to build the code, put it in containers, put them on Docker Hub, or put them on the Amazon Container Registry. And then our build system is going to deploy it by using kubectl -f serviceall.yaml, and it's going to deploy the new application. Now, Kubernetes is going to manage things. If nodes fail, they'll be recreated. The EC2 instances will be recreated for us if they fail. If pods die, they'll be re-added. If containers die, they'll be reconstructed. We can monitor the health of different containers. This is more advanced, obviously, in Kubernetes, but we can do those sorts of things as well. And it will manage this system without any human interaction. You know, if servers are failing and apps are crashing, it will try and get back to that best case scenario without any human interaction at all. So this saves time, money, allows us to move faster, reduces overwork. So you might be thinking, well, that's great, but why do I have to have EC2 instances that make up my cluster? I really just want, I'll give you my containers and you run the containers. Well, we have added support for that as well now. So with Fargate. Now, Fargate used to only work on the other container orchestrator, ECS, but it now also works with EKS as well. And what this allows us to do is just bring your container pods, run them using Fargate, and then it runs in a cluster which is not managed by you. So you don't actually own the machines, the EC2 instances. If you looked in your account, you wouldn't see any EC2 instances. The containers will run on Fargate, basically in an AWS managed cluster, which is completely private and completely separate. And you don't have to worry about scaling it. You can just add, I want 6 of those containers. I want 100 of those. We scale the cluster back and forth. We manage all of that complication. And you just benefit from running your containers without having to worry about the underlying infrastructure at all. So it's a thing to think about, when we're doing this. So Okay, so we've got our, we understand a little bit about Kubernetes now. We understand about containerizing our application. So let's just have a look at an application. And if you have a device, use your camera application now and just point it to the QR code, or go to the website pirate.thebeebs.net. And you should see a screen which says something like this: please wait. Hopefully a couple of you are joining in on this. And this is the application that we're running. When I click through there, it says, what do you want to drink? Coffee or grog? So there's one person there which is joining in. Gone to the website and said coffee or grog. I'll choose coffee just to make things all equal. And so, another person's joined in. Great. So if you go to pirate.thebeebs.net, you can vote on this. And basically now, because this is running in Kubernetes, we would be able to take this to a much higher scale and hopefully make it more reliable than potentially if we were just running it on raw EC2 machines. Another question: do we want to do sword fighting or pirate curling? Are they the best? Which is the best? Which is going to win the pirate festival best? I'm just going to go for pirate curling myself. Just a few more of you joined in. That's good. It makes me feel better when there's actually a little bit of interaction. So thank you very much for that. But yeah, we've built our application. We've done what the CTO wanted us to, which is to make this application more reliable. I've shown you how you can containerize a .NET application, how you can put that containerized application into AWS, and how you can run it very briefly on Kubernetes. That's all I wanted to say to you. So thank you very much. My name is Martin Beeby. I'm at the Beebs on Twitter. And if you have any questions, then I'm able to take them.
Hey, Martin. Thanks a lot for the cool slides. I really like them. Yeah. So we got a couple of questions asked in Slido. So thanks for that. The first question is, how about .NET application deployment to Fargate? Is it supported? What features Fargate is provided as especially for .NET application? So are there any .NET specific features?
No. So the thing you need to know about Fargate, so Fargate sometimes sounds like it's its own service. It's not. There's EKS and there's ECS. They both support the launch type of Fargate. It's confusing, but the Fargate team are really adamant that you make that distinction, that it's a launch mechanism. And that's because some people assume Fargate only works on ECS, but it doesn't. It works on both these things. So yes, you can use Fargate with EKS, which is what I was talking about towards the end of the talk there. There are some consideration for .NET developers. I mentioned before the EKS, you can have Windows containers, so Docker containers that have been not that built on Windows. What I mean is that they're actually inside the container, they're running the Windows operating system. So they're running their Windows containers. And you need those if you want to run really legacy applications or applications that only run on Windows, and they can't be moved to .NET Core or .NET 5. Now, those kinds of applications, they run on EKS, but you have to build your own cluster, and you have to build your cluster in a special way to allow, basically the EC2 instances, which underpin your cluster, some of them have to be Windows nodes. And you can have a mix of Linux and Windows nodes, but we will if you spin up a Windows container, we will put that container on some of the Windows nodes. If you spin up a Linux container to support Redis or something, I don't know, or a database, we would put that on the Linux nodes maybe. So you get to choose which nodes inside of your cluster you put certain things on, but you need Windows nodes underneath to be able to run Windows containers. Now, if you're building in .NET 5, that isn't, or .NET Core, that isn't a problem, because all of your containers are you could build them as Linux containers. Now, Fargate only works with Linux containers, and that's the caveat, is that we don't have a pool of Windows machines as part of that Fargate thing that we manage. So we can't run Windows containers on Fargate, but we can run Linux containers. So for .NET developers, they need to consider, well, if I need to run Windows containers, then I can't use Fargate. But if I am using .NET Core or .NET 5, then I could use Fargate for that. And in my opinion, like, why not use Fargate? Like, why do you want to have to manage any machines? Like, it probably, in most instances, is a better choice. But there are genuine reasons why someone would want a little bit more control over their cluster. But I would say there are some exceptions and certain things you have to think about. But as a regular .NET developer, if you're building .NET Core or .NET 5, then you can absolutely run that on Fargate.
Thank you. So we got 2 more questions, and we got more questions basically, but I'm asking the most voted one. So, which setup is more cost efficient, like 2 ECs behind a load balancer or a cluster with 2 containers in it? In other words, do we need to pay more for reliability?
Right. No, you're exactly right. So having 2 EC2, so having a cluster of 3 EC2 machines versus 2 EC2 machines, that doesn't make much sense at all. However, if we were to use Fargate, then a containerizer application just use Fargate, you actually only pay for the containers. You don't pay for the nodes which are under sitting it. So there's another good reason to use Fargate is that you then only pay for the actual portion that you use. And that's why if you're ever thinking about running a containerized application on either ECS or EKS, like really think about using Fargate, because especially when your applications are quite small and there's only like 2 or 3 containers, you're right, it doesn't make sense to have a big cluster and then only utilize a small portion of it. Most customers have bigger applications than a couple of containers. So in those instances, they'll having their own cluster and managing that works out. But Fargate is great for that sort of thing. So quite often I'll build an application. It's not complicated, doesn't have that many dependencies, and it's maybe only a couple of containers. I almost always run that in Fargate, because using EKS on Fargate or ECS on Fargate, because I'm only then paying for the containers and the cost of the container which is running. So if I scale up to 10 containers, I pay for 10 containers. If I scale down to like 2 containers or 1 container, I pay for that 1 container. It should cost less if you architect it correctly, but you're absolutely right. You could quite easily get to a situation where you've got a very big cluster and you're not using any of it.
Yeah, thank you. And my favorite type of questions, Holy questions. Are there benefits of using AWS environment comparing with any other cloud providers? Azure is quite good in managing Kubernetes clusters for .NET applications.
Okay. Yeah. Okay. I mean, they might be. I mean, that's not necessarily. I'm sure they're very good at handling Kubernetes. I would say that we have the most experience and we have the largest volume of customers. So it was said quite recently, like 70% of customers that build containerized applications on Kubernetes use AWS. So like we have lots more people running at a lot bigger scale. And with that, because we've been doing it for longer, that gives us a certain level of like maturity and reliability and stuff. Like, I don't think it's helpful to compare necessarily AWS to Azure or Google and think, the reality is, you're as a customer, you're going to choose the best one for you. And that the best thing for you as a customer might very well be Azure. Maybe you've got customers which are familiar with that. They understand how Azure works. They're happy with the scalability and the reliability. They're happy with the way that they do availability and regions and things like that. But then, if you genuinely want like best performance, in our opinion, best price, then of course, then AWS will be there for you. But, if you're thinking about using AWS or Azure, then just come speak to us and we can explain on a case-by-case basis why we think we're better in that scenario. But it doesn't help anyone to say, oh, they don't do this or they do this. It's just, choose whichever works best for you. And that goes not just for Azure versus AWS, it also goes for the container platforms, ECS versus EKS. And I'm sure there's other container platforms on other cloud providers, things like OpenShift and all sorts of other ways of running container applications as well. Some of them will be more familiar to your developers. Some of them will be a better fit for your developer. Choose the one which is best for your team and your company.
And nobody liked Google Cloud. So yeah, like there is one more.
Everyone likes there's always someone which likes Google Cloud. In fact, I would give credit to them when it comes to Kubernetes and running that. I mean, they invented Kubernetes. They have a very lovely interface for managing Kubernetes.
Oh yeah.
And if that is your thing, if you want an easy web interface to run Kubernetes, then they do a really good on the onboarding of it's fantastic. But we do think that the best place to run Kubernetes applications is AWS, without a doubt. But I would say
thank you. Thanks for the answer. And there is one more question which like people are voting for it. Microservices with serverless. What is the future? What will you prefer?
Well, it's interesting when you say the word serverless. AWS have been pioneers of serverless. We had the Lambda service, which is a serverless service. Like basically you write the code, it runs in micro virtual machines. They're like little containers, these little pieces of code, they're invoked. It's event-driven architecture. I think personally, that's absolutely the future. And what's interesting is though, containers are blending into this world as well. When I talk about Fargate, that's basically running containers serverlessly. You're giving us your container, we run it under the hood, you don't have to worry about it at all. You can now, even with AWS Lambda, you can take a container and use that as your Lambda function. So we have container support in Lambda. So I think containers are like becoming the standard way of packaging pieces of software. But I am all for the evolution of serverless and doing more with it. A few years ago, serverless was all about, creating simple functions and doing simple things in the cloud. Now there are companies out there building entire architectures, complex systems, all built around serverless. We have a customer in the UK, it's a charity called Comic Relief. And they have a telethon every year where people phone up and they donate money to a charity, to Comic Relief. And it's a big TV event. Millions and millions of pounds are raised in one single night. And they were having huge problems with reliability. They moved to AWS Lambda, and their hosting charges for that one night or that month, about $85,000 for that application. They moved to Lambda. They have the same application, far more reliable. It's got more into it. And they run it, the exactly same application or a similar application for $7,000 a night. So their hosting charges were reduced by like 92% by moving to serverless. More responsive, more scalable, more reliable with a 92% cost reduction. There's really good reasons to look at serverless and think about serverless. And if you're a .NET developer, you can build serverless applications in Lambda with containers on Fargate. You can use serverless databases like DynamoDB. It's all for the taking. So .NET developers definitely look at serverless and serverless technologies in general.
Thank you. Thanks for the answer. We need to move, but what was your favorite question from our audience?
I really enjoyed that one about the serverless, but I do quite like it when you put people like me on the spot and ask me about competitors, because it's really uncomfortable. But I quite enjoyed the challenge of talking respectfully about our colleagues in Seattle.
Thank you. Thank the person who asked about Azure question. Just contact our administrator in the group so we can contact you and send you some bonus. Thank you, Martin. That was a delightful speech and I think the most beautiful presentation I ever seen in technology event. So thanks for that.
Can you write that down for me for my LinkedIn? Can you do that as my recommendation? The most beautiful presentation.
Yeah. Will do.
Thanks, man.
Thank you. Thanks for your time. And I'm looking on my script. 1 second. And і ми переходимо знов на українську мову. А ми тим часом переходимо до нашого наступного другого спікера. Зустрічайте. Павло Голубович, лід софтвер інженір в компанії NX. У Павла 8-річний досвід роботи в експертизі .NET. На даний момент він працює над розробкою мікросервісних сорюшенів в AWS. Павло розкаже, як розгортати AWS-інфраструктуру в корпоративних рішеннях, розглянемо декілька підходів і з'ясуємо, чому він використовує Pulumi. Я сподіваюся, що я правильно сказав назву цієї технології. Павло, тепер ти.
Всім привіт. Дякую за такий інтродакшн. Так, я сподіваюся, що після презентації принаймні всі вивчать, як правильно називати Pulumi. Так, і сьогодні я розкажу про Infrastructure as a Code і чому класно для цього використовувати Pulumi і C#, і чим нам не підходять ті рішення, які використовуються на проєктах вже досить довгий час, і чому, власне, ми використовуємо на своїх проєктах Pulumi. Тут Діма вже трошки про мене розказав. Та я себе вважаю full-stack інженером, який може зробити все від фронтенда до DevOps. Мені подобається працювати з веб-солюшенами і з клаудами. Я працюю не тільки з AWS, а також і з Azure Cloud. І Pulumi дозволяє поєднувати обидві клауд-платформи, і це дуже круто. Коли ми говоримо про сучасну архітектуру, попередній доповідач якраз дуже багато про це розказував, що вона дуже сильно ускладнилася. Ми починаємо використовувати якісь кластери контейнерів, запихати то все в якийсь клауд, а потім виявляється, що в одному клауді щось реалізовано трошки краще, ніж в іншому, а ми хочемо отримати вершки зі всього ринку, і часом ми якось поєднуємо, часом є якісь полісі, які заставляють нас використовувати певні сервіси або не використовувати певні сервіси. І ми надзвичайно складно ускладнили архітектуру застосунків. Якщо 10 років назад домінуючою силою, принаймні в світі .NET, були моноліти, які деплоїлись просто зазвичай на якісь там on-prem сервіси на AES, і там кожен .NET-чик мусив вміти його розгорнути, задеплоїти, і досить часто це все робилось руками, то зараз так вже не виходить. Дуже багато застосунків є клауд, і вони ускладнилися. Тут можна побачити референс-архітектуру для AWS. І насправді це не є щось дуже складне. Це просто звичайний веб-сайт, який хоститься через автоскейлінг групи в двох availability зонах і використовує ще кілька сервісів AWS. Але бачачи, скільки тут є айтемів і скільки прямокутників, в яких вони покладені, можна зрозуміти, наскільки важко це все застапити. Але якщо ми сетапимо це тільки в одному екземплярі, це, в принципі, ще можливо. Однак, коли ми доходимо до enterprise розробки, то в enterprise розробки в нас появляються environment. І ті environment часом потрібно створювати ледь не щодня. Наприклад, щоб запустити автотести ввечері на чистій машині і потім її благополучно потушити через годину після того, як ті тести впали. Або пройшли. Було б добре, щоб пройшли. Так, і виходить так, що якщо навіть в нас немає оцих от рекурентних створень видалень енвайрментів, то все рівно, маючи хоча б там три енвайрменти, то вносити зміни в кожен з них, це стає дуже великою рутиною, і для цього потрібні дуже дорогі люди девопси, яких зараз дуже важко знайти. І це просто дорого саппортити. І, можливо, це стане занадто дорого для того, щоб ваш проект залишався в профіті. Тому вже досить давно придумали таку штуку, як Infrastructure as Code. Що вона робить? Спочатку ми пишемо код, потім ми пропускаємо його через систему контролю версій, ми можемо зробити код-рев'ю, ми можемо інтегрувати це в якісь валідаційні тули, щоб ми розуміли, що ми робимо правильно, що ми не робимо якихось помилок, і потім ми можемо це все задеплоїти вже до клауд-провайдера, в даному випадку AWS. І тут ми можемо бачити, що це цілком звичайний пайплайн для нашого звичайного коду. Тому що це теж є софтвер, просто інший рівень. І так дуже зручно, коли ми можемо використовувати наші development best практики також на тому, як саппортити нашу інфраструктуру. Pulumi – новий гравець на цьому ринку. Його створив інженер, який звільнився з Microsoft і створив open-source компанію, контрибутить його, по-моєму, зараз 16 людей. Щось таке я дивився. Тобто це все ще невеличка компанія, але вони мають дуже широкий саппорт дуже багатьох речей і, як на мою думку, перемагають оцих от компетиторів. Тобто, якщо ми спитаємо там DevOps якогось такого дуже консервативного, що таке Infrastructure as a Code, я думаю, що він майже одразу захоче сказати щось про Terraform. І Terraform зараз домінує, його знають, його використовують, і він допомагає вирішувати цю задачу доволі ефективно. Також в Azure є ARM-темплейти, в AWS є CloudFormation, які дозволяють також тримати конфіги інфраструктури разом з кодом проекту і якось його там редагувати. На мою думку, темплейти – це є дуже велике зло, яке приносить дуже багато копіпасту, але ми потім порівняємо, наскільки ефективно можна їх використовувати і наскільки краще чи гірше буде виглядати Pulumi. І так, що нового привніс Pulumi в оцей от світ Infrastructure as a Code? По-перше, вони ввели звичайні programming language. Тобто нам не потрібно вчити щось нове, ми просто пишемо на зручній мові. Ми тут .NET-інженери, напевно, що хотіли би використовувати C-Sharp, F-Sharp. Якщо в нас є фронтенчики, machine learning чи ще якісь специфічні задачі на проектах, то вони також можуть використовувати. І що класно, що це не конфліктує. Тобто, якщо ми маємо мікросервіс, який містить тільки фронтенд, або там якась нода, то ми все ще можемо писати Pulumi код на TypeScript, а в наших .NET рішеннях використовувати C-Sharp чи F-Sharp. Що ще класно, ми користуємося своїми звичайними тулами. Тобто, кому подобається Visual Studio, Rider, VS Code, ми можемо використовувати, ми маємо IntelliSense, ми знаємо всі ходки, форматінг, і це, звичайно, пришвидшує розробку. Також ми, завдяки тому, що це є код, ми аплаємо всі код best practices, ми можемо там навіть навісити якийсь static analyzer, так як це звичайний C# код, і просто хендлити його як бізнес-логіку. Pulumi саппортить багато клаудів і має дуже багатий Kubernetes саппорт. І це дуже класно, тому що якщо ми використовуємо темплейти, нам треба вивчити два світи. Звичайно, коли писати Pulumi код для деплою на різні клауди, треба розуміти специфіку, але використовуючи звичайну мову програмування, це значно простіше зрозуміти, так як є підказки. Так як це звичайний C# чи TypeScript код, ми можемо писати на нього юніт-тести і таким чином перевіряти наші конфіги, наскільки вони хороші. Pulumi працює в декларативному режимі, тобто ми не переживаємо на те, як досягти якоїсь конфігурації системи. Ми просто кажемо, що ми хочемо отримати. В Pulumi під капотом є порівнялка того стану, який у нас є зараз, того стану, який ми хочемо отримати, і він автоматично генерує екшени, які потрібні, щоб перейти з одного стану в інший. Так, також ми можемо дуже класно колаборувати з DevOps-інженерами через ті ж код-рев'ю pull-реквестів. Якщо DevOps хочуть не віддавати нам цю розробку, то ми все ще можемо їх якось контролювати і краще розуміти, як це все відбувається. Там є дуже класна інтеграція з CI/CD. В платних версіях ми можемо деплоїти з command-line інтерфейсу, так само там саппортяться практично всі сучасні CI/CD системи. І ми можемо приборкати складність таким чином, що ми можемо побудувати якусь структуру класами, побудувати через змінні, через якийсь storage і розуміти, що в нас йде за чим, що використовується де, бачити ці зв'язки і таким чином краще розуміти, як працює наша інфраструктура. Ще дуже класна штука – це є полісі. Полісі, які можуть бути обов'язковими або не обов'язковими. Якщо полісі обов'язково, в нас просто не пройде деплоймент. Якщо полісі опціональна, то ми отримаємо ворнінг, який зможемо прочитати і виправити його, скажімо, в наступному коміті. В полісі є дуже широкий саппорт того, що ми можемо там використовувати. В даному випадку ми можемо побачити, що S3-бакети повинні не мати публічного ріду і публічного запису. Таким чином ми додаємо і security, так як написати не ту галочку в темплейті чи створити його з UI значно простіше, ніж якщо в нас прописана полісі і ми її використовуємо. Як це працює? Все крутиться навколо command-line інтерфейсу і енджину, який під капотом зберігає стан. Коли ми використовуємо платні версії Pulumi, цей стан зберігається на сервері, однак ми можемо його перемістити собі на локальну машину. Однак Pulumi запевняє, що все дуже секюрно, все дуже класно і найкраще використовувати так, щоб останній задеплоєний стейт зберігався вже на сервері, а не десь там в нас. CLI Engine читає з language хоста ті скрипти, той desired state, який ми там описали, і генерує команди через command line на провайдери. Pulumi саппортить також і Google Cloud, хоч він тут не описаний, і там є ще дуже багато таких маленьких провайдерів, які ви можете перевірити потім на сайті. Що важливо? Важливо не вносити зміни руками. Не вносити зміни через темплейти, не вносити зміни через Terraform, тому що може привести до якихось неочікуваних результатів. Якщо ж ви все рівно хочете, щоб це було якось жило разом, то потрібно ізолювати, тобто, щоб воно не було в переміжку, щоб Pulumi сервіси не використовували ті сервіси, які ви створили якимось іншим методом. І найбільша проблема Pulumi – це те, що воно коштує грошей. Всі хороші тули коштують грошей, за частину з них ми вже привикли платити, як ідешки, як там ліцензії Windows, за дещо не завжди. В нас тут є ком'юніті фрішна версія, однак її використовувати в продакшені практично неможливо, так як вона тільки для одного мембера, і це нема в нас таких команд. Також є стартер для маленьких команд, однак там немає повної підтримки всіх API веб-хуків і підтримки повної CI/CD. Тобто ми повинні дивитися вже на про-ліцензію. Про-ліцензія за $225, вона включає вже 3 мембера. Тобто кожен користувач Pulumi обходиться компанії в $75, якщо платити за рік. З одної сторони, це не так дешево, і потрібно використати всі свої communication скіли, щоб переконати менеджмент, що це потрібно. З іншої сторони, якщо дивитися на рети DevOps-інженерів, і який час ми можемо їх зекономити, то це не так дорого. Плюс ми не змушені купувати ці ліцензії всім розробникам. Тобто цим можуть займатися, скажімо, тільки ліди, а девелопери використовувати вже просто читати ці конфігурації. Ну і, звичайно, що є Enterprise. Enterprise Pulumi вважає, що це, якщо в нас є більше 25 тім-мемберів, і там вже прайсинг є дуже індивідуальний. І так, чим нам не підходить Terraform? Terraform, ну, ніби ж всі ним його бачили, чули, і він вирішує всі задачі. Однак його дуже важко вчити. В нього є дуже специфічна мова, їхній configuration language. І все рівно, коли ми використовуємо наші рідні C-Sharp, F-Sharp, ми знаємо, як там використовувати цикли, як там використовувати змінні, як це все гарно відформатувати, порозносити по файликам. І ми отримуємо справді flexible, гарний код, який добре читається, легко саппортити, легко рев'ювати. Також в Pulumi є доступне юніт-тестінг, що дуже важливо для складних інфраструктур. І Pulumi має значно кращий Kubernetes саппорт. Тобто, якщо говорити про Terraform, то всі завжди дуже жаліються, що деплоїти Kubernetes через Terraform дуже-дуже важко. З переваг Terraform це те, що він безкоштовний. І це, мабуть, той геймченджер, який не дозволить Pulumi завоювати світ дуже швидко, так як вибивання бюджету ніхто не відміняв. Навіть якщо ми використовуємо Terraform Cloud, тобто цей стейт, про який я говорив раніше, зберігати не локально, а зберігати його в клауді, то це все рівно коштує $20 для розробника. А в Pulumi, виходить, майже в 4 рази дорожче. Також на даний момент, так як Terraform це вже устоялне рішення, а Pulumi молода тула, то ми маємо значно більше ком'юніті, нам значно легше знайти вирішення якоїсь проблеми на Stack Overflow, і також в них є значно більше документації. Я не можу сказати, що документація Pulumi є якась бідна і недостатня, однак все-таки Terraform більш продокументований. Також, якщо ми порівнюємо з CloudFormation, з темплейтами, то тут є ще більше переваг. В першу чергу це мультиклауд. Якщо в нас є і Azure, і AWS, то нам потрібно використовувати 2 темплейти. А в Pulumi вміє і одне і інше. Також, на мою думку, використовувати JSON і YAML дуже сильно ми втрачаємо в readability тих конфігурацій. Появляється дуже багато копіпейсту, і дуже багато інженерів не розуміють, що там відбувається, і ми отримуємо якісь бездумні сервіси, які ніхто ніколи не використовує. Знову ж таки, юніт-тестінг, який ніколи не потрібен, недоступний в CloudFormation. Ми отримуємо кращий Kubernetes support, і ми отримуємо прев'ю. Тобто перед тим, як внести якісь зміни, ми можемо зрозуміти, що саме буде відбутися. З переваг CloudFormation це те, що в нього є більший саппорт фіч. В порівнянні говорили, що CloudFormation підтримує приблизно 500 фіч AWS, Pulumi близько 400. І це співставно з Terraform. Коли в AWS виходять якісь нові фічі, завжди є якийсь геп між тим, як він появляється навіть в CloudFormation, і тим більше в Pulumi і Terraform. І в той період ми повинні використовувати якісь command-line скрипти, які дозволять якось забезпечити деплоймент, якщо ми хочемо використовувати прямо зовсім нове. І також дуже важливим, чого в нас бракує в Pulumi, це є rollback. Rollback в CloudFormation відбувається при будь-якій ерорі при деплойменті. Pulumi цього не саппортить. Однак ми можемо використовувати той же exception handling і написати ті ролбеки самостійно. Зараз я хотів би показати демо, як це все відбувається. В демо буде присутній AWS Lambda з контролером Values Controller, який має просто HTTP GET controller, і який повертає value 1, value 2. І в нас є, тобто є окремо проект API, і є окремо проект з Cloud Infrastructure, з Pulumi. Що ми повинні тут засетапити? Нам потрібен Pulumi YAML для того, щоб показати Pulumi, як описати наш проект, описати, в якому рантаймі ми використовуємо це. І нам потрібно прописати AWS Region, який ми використовуємо по дефолту. Все фактично це є звичайна консоль application, який входить в програм, в static main, і static main запускає run mystack. Що ми маємо в mystack? Ми маємо роль, яка створюється через new. В ролі ми можемо, знову ж таки, зайти, подивитися, що це за клас, і які в нього бувають параметри. Це дозволяє не гуглити документацію, а просто подивитись код і використати ті параметри, які потрібні. Також ми створюємо Lambda API, знову ж таки, через function, який є такий самий C# клас. Прописуємо property, на все нам доступні IntelliSense, і це дуже зручно. І відразу ми можемо, скажімо, resource name прописати до створення нової функції. Той resource name, який ми створили отут от в Lambda ролі. І на вихід ми, скажімо, помічаємо property output і прописуємо, що нам API URL, який ми прописали в API Lambda, він нам повернеться. Так, краще. Окей, так. І для того, щоб задеплоїти функу, нам потрібно її збілдати. Звичайно, що це такий колінний варіант, і потрібно, щоб це робилося білд-машина, однак ми одним з параметрів передаємо файл-архів цієї функції. І от, власне, отак от виглядає наш деплоймент. Також ми можемо подивитися, як виглядає deployment proxy API. Тобто це не так просто задеплоїти функу, але ми можемо дуже гарно бачити, як воно все читається. Ми можемо використовувати параметри, можемо використовувати конфіги, так як це звичайний консоль application. І для порівняння, коли ми подивилися на оце от все, можна подивитися, як би це виглядало, якби ми використовували AWS template. Тобто це є JSON, який має параметри, який не має ніякого навіть підсвітки. Мабуть, якщо поставити якийсь плагін сюди в Rider чи Visual Studio, якщо такий вже створили, то підсвітка буде. Але все рівно нам треба буде дуже багато досліджувати документації, щоб зрозуміти, що потрібно. А також досить часто, мабуть, коли нам треба буде додати, скажімо, нову AWS-функцію, ми просто візьмемо функцію, там десь скопіюємо Ctrl-C, Ctrl-V 2 рази, поміняємо name і отримуємо дублікат бездумно, не задумуючись про те, що було тут всередині, і пропустимо досить багато якихось важливих параметрів, які би нам поміг звернути увагу IntelliSense. Давайте подивимося, як воно все виглядає. Тобто все керується з консолі. Спочатку я би хотів показати, як виглядає прев'ю. Це займає якийсь час. Якщо використовувати платну версію, то там де пріоритет на ті всі черги, і воно відбувається значно простіше. Тобто ми бачимо, що нам потрібно створити 10 ресурсів, і план буде на створення. Для того, щоб запустити це створення, давайте подивимося, що в мене там нічого нема. В AWS консолі. Тобто от в мене є лямбда функції, ми в Північній Вірджинії, і тут нічого немає. Також, коли ми відкриємо URL, то сторінка недоступна. І тепер нам потрібно запустити Pulumi App. І на основі того стейту, який ми задали в конфігурації, буде знову ж таки нам показаний план. І після того, як ми підтвердимо або не підтвердимо апдейти, він буде задеплоєний на AWS. Все це відбувається досить швидко, на мою думку. І досить просто ми бачимо весь процес. Також ми можемо побачити його і на сайті Pulumi. Всі попередні процеси, які відбувалися. От тут видно, що це вже апдейт 7-й мій. І ми бачимо всі статуси, тобто якась частина створюється, якась частина вже створена. Так, і все створилося, ми отримали output API URL, і коли ми на нього перейдемо і додамо API values, то ми бачимо, що у нас працює контролер, і таким швидким маневром ми задеплоїли AWS Function на мій AWS аккаунт. Коли ми перефрешнемо тут, то ми бачимо, що воно вже тут є. Так, тобто так воно працює, і також ми можемо знищити ті всі ресурси, всі, що нам потрібні, для цього використовується команда destroy. То якщо ви пишете щось там в синбоксі, чи ви просто підняли аккаунт, щоб щось потестити environment, і треба почистити, щоб економити гроші, одною командою ми все знищуємо. Ми мусимо це, звісно, підтвердити. І воно все знищиться приблизно за такий же ж період часу. І ми бачимо результат, що все видалено. Також, якщо ми поміняємо щось одне, то в нас буде вже не план на створення, буде план на модифікацію тільки того, що нам потрібно. Тобто порівняння стейтів працює досить добре. Не хочу тратити час просто, щоб це показувати. Так. Що я хотів би ще розказати про якісь поради від мене, як організовувати такий процес. Дуже важливо вибрати мову. Коли ми працюємо в cross-functional командах, у нас часто є якісь фронтенщики, machine learning інженери, які можуть не знати C#. І, можливо, варто використовувати або всюди мову, які всі будуть розуміти, таку як JavaScript, TypeScript, або використовувати ту мову, на якій написаний конкретний сервіс. Також дуже важливо ввести леєри цього інфраструктури коду, тобто, щоб весь код не був разом з сервісами. На кожному великому проєкті є якась інфраструктурна загальні речі, наприклад, централізовані логи, є якийсь моніторинг, алерти, і це все повинно лежати в окремому репозиторії, де буде лежати тільки Pulumi код. І він буде мати особливий пайплайн, але також ми будемо мати версію, і ми будемо розуміти, що перед оцим великим релізом у нас обновилася інфраструктура, і нам спочатку потрібно задеплоїти компонент інфраструктури, а потім вже деплоїти наші сервіси. Також, якщо у вас є якісь специфічні клієнти, які мають ізольовані енвайрменти, мають дещо інші енвайрменти, ніж інші клієнти, якщо є якісь шарені ресурси не на основі всієї платформи, а ізольовані під якусь там маленьку частинку, то, можливо, потрібно ввести ще один лаєр для цього кастому. І тоді вийде так, що у вас є платформенний репозиторій, у вас є репозиторій під кастомера, і у вас є infrastructure код в кожному сервісі, той, який відноситься до сервісу. Тобто загальні речі ми створюємо і реюзаємо вже їх в сервісах. Також дуже важливо тримати deployment діаграму up-to-date, так як з леєрами, з мікросервісами дуже легко запутатись. І щоб не наробити якихось помилок, щоб не використовувати якісь зайві ресурси, дуже важливо тримати це все на картинці, щоб кожен міг зайти, подивитися, чи є вже такий ресурс, чи потрібно його створити, чому оце лежить в цій availability зоні, чи в цьому регіоні, а це лежить в якомусь іншому. І так ви зможете керувати тим, які зміни робилися в інфраструктурі помімо код-рев'ю. Дуже важливо використовувати код-рев'ю, дуже важливо, щоб до цього ставитись дуже серйозно, так як інфраструктура часом це дуже великий ризик. Якщо зробити там помилку, можна отримати дуже великий рахунок від клауд-провайдерів, і таким чином можна зафейлити всі цілі на найближчий квартал чи ще щось. І для нових фіч, які не саппортяться Pulumi чи такими рішеннями, як Terraform, потрібно використовувати CLI. Навіть не щороку, скоро будуть. Почекати деякий час, і вони з'являться, і ви зможете той CLI-код поміняти на власне нативний C-Sharp-код. В мене, в принципі, все. Які є запитання?
Огонь, Павло. Дякую. Я тепер знаю, як казати Pulumi. В нас є досить багато запитань, і почнемо ми з першого. Які суттєві відмінності від Pulumi та AWS SDK або Serverless Application Model CLI, які також підтримують TypeScript?
Власне, на мою думку, це є інтеграція з CI/CD, яка значно більш йде гнучкою в Pulumi. Це підтримка не тільки TypeScript, і це є мультиклауд рішення. Якщо у вас використовується не тільки AWS, а ще й Azure, чи у вас є серйозний Kubernetes кластер, то використовувати нативні AWS рішення буває недоцільно, і це тільки ускладнює.
Дякую. Наступне запитання. Якщо тільки починаєш вивчати модель Infrastructure as Code, краще працювати з Terraform, який зараз найпоширеніший, чи з Pulumi, який набирає популярність?
На мою думку, Terraform є досить складний для того, щоб починати його вивчати. І я би почав з Pulumi, так як рано чи пізно, я думаю, що він отримає досить великий відсоток ринку, а Terraform вже має досить багато інженерів, які його розуміють, які його використовують і будуть використовувати. Чисто
Дякую.
За рахунок того, що воно простіше і легше буде втягнутися в переваги Infrastructure as Code.
Дякую. Наступне запитання. Якщо тільки починаєш вивчати модель Infrastructure as Code, краще працювати з Terraform, який зараз найпоширеніший, чи з Pulumi, який набирає популярність? Зрозуміло, дякую. Тут же в чаті люди кажуть, що хочуть кидати Terraform і йти на Pulumi, так що продав.
На сайті Pulumi є навіть гайд, як переходити з Terraform на Pulumi. І взагалі вони там дуже класно описують, що нема взагалі нічого навіть близько подібного до них, які вони молодці. Тому, якщо є таке бажання, то зайдіть на сайт, вам додавать впевненості.
Але не забувайте, що завжди треба бути обережнішим в виборі стеку. Наступне питання. Чи вміє Pulumi обробляти неявні депенденси між ресурсами? Наприклад, при дестрої інфраструктури.
Це важко сказати, так як інфраструктуру дестроїти в мене не так часто вийшло, тобто ми зазвичай вибивали весь environment і вбити все досить просто. А трекати, тут треба тестити. Я не можу сказати про конкретне рішення. В нас ніяких проблем з цим не було, але видаляли мене так багато.
Угу. Дякую. Цікаве запитання. DevOps на рынке не найдешь. А как же искать DevOps, который в Pulumi разбирается?
Суть в тому, що ви можете не шукати DevOps, а дати вашому C# senior розробнику декілька годин почитати документацію, і він зможе це застапити. І це велика перевага, тому що і потім вони перейдуть в DevOps.
Дякую. Ще одне запитання. Пробували ли AWS CDK? Я так розумію, C не путати з SDK. И наступный сразу же, как часто сталкиваетесь с тем, что Pulumi не умеет разворачивать какой-то ресурс?
З цим можна зіткнутися, якщо у вас не є якісь супер rare кейси, тільки якщо використовуєте free tier. Є абсолютно достатня підтримка всіх ресурсів, і ми не стикалися з тим, що треба було щось дописувати. Тобто за це, звичайно, треба перевірити, але в нас таких проблем не було. З CDK не користувалися, зокрема, і через те, що він тільки AWS.
Окей. І, напевно, останнє запитання. Це, напевно, більше запитання по Terraform, але як насчет использования CDK for Terraform як альтернатива HCL? Господи, скільки абревіатур.
Я боюсь, не зможу відповісти на це запитання. Не зовсім знайомий з тим, як використовувати CDK з Terraform замість HCL.
Окей, тоді міняємо запитання. Як спрацювати з креденшалами в Pulumi і які best practices по security?
Pulumi використовує логіни через Identity Access Management. Ви створюєте Identity Access Management роль, і в Pulumi також є свій логін. Тобто кожен, хто заходить, чи це якийсь ICD pipeline, чи це якийсь розробник, він має залогінитися в консолі, і через IAM можна похендлити всі ролі.
Дякую, Павло. Яке запитання тобі найбільше сподобалось?
Найбільше сподобалось про ролі.
Ролі? Так, це останнє?
Так.
І так, зараз це Роман Дзюма. Будь ласка, зв'яжись з адміністраторами, і вони вишлють тобі подарунок. А ми, Павло, дякуємо тобі за цікаву доповідь і гарного завершення дня тобі.
Дякую.
Дякуємо. І ще одна новина. Гей, всі, хто сьогодні, до 23 квітня, подасться на .NET вакансії від NX, отримує sign-on бонус. Умови. Значить, треба надіслати резюме в період з 15 до 23 квітня на будь-яку .NET позицію Middle+. Пройти співбесіду, коли зручно. Отримайте welcome бонус, якого точно ще не мають друзів та знайомих. Новенький PlayStation 5. NX, ну і ті же, давайте я вас викуплю PlayStation 5. Я же за Сонькою 4 місяці ганяюсь, а ви от можете отримати, якщо подастесь і пройдете співбесіду. Де вони їх беруть, невідомо. Але лінк на відкриті вакансії ви знайдете в описі трансляції. Що ж, і наступний наш спікер. Він з AWS, це Senior Developer Advocate Amit Jha. Amit, I'm very sorry if I mispronounce your last name, like with the first speaker. Amit has 20 plus years of industry experience. In his current role, Amit focuses on architecting on AWS, optimizing AWS environments, and helping customers and partners with cloud adoption, with special focus on Microsoft.NET workloads. Speaker prepared a demo session for .NET developers, architects, development leads who are exploring, building, deploying .NET applications on AWS. Let's start. Amit, the stage is yours.
Thank you. So I just learned how to greet Vitaju. Vitaju, hello. Is that right?
Yeah. Vitayo. That's great.
Vitayo, everyone. Vitayo. So let me quickly make sure you can see me, you can hear me, and you can see my deck.
Yes, we can.
Are we good?
No,
Awesome.
we can't see your deck.
You can't see my deck. I am sharing in the Zoom. Let me share again. Now. Okay, as in you are able to see it? Okay, wonderful. Thank you. So welcome. What I'm going to do is I'm going to quickly give you a run through of .NET support on AWS. So it'll be a good amount of demos filled with all the tool sets that we have. So let's see. Here's what I have agenda. Go through AWS Primer, go through AWS tools for .NET developers. And as we talk about .NET, usually there is legacy .NET based applications like .NET Framework based applications, and then the newer .NET Core, .NET 5 based applications. So understanding how do you actually bring those workloads, applications onto AWS? How do you modernize those applications on AWS? We'll touch upon those, and it's not just about like getting your application working, it's also about productionizing. So essentially, how do you do monitoring? How do you do identity tracing? So I want to club a lot of information in this next 40 to 45 minutes. So let's get going, right? First, before tech, it's the business. So you have to have a right clarity on what your business goals are. I work in New York with a lot of financial services. Some may have the needs to grow their revenue streams. Some they want to just have an improved operations and financial efficiency. So the conversation has this kind of typical top level goal, be it revenue, cost, agility, innovation. Having that clarity is super, super important, right? Some customers have digital transformation as their top level goal. Some customers have agility and staff productivity. But getting that top level goal is super important. And that trickles down to the leaf level employee. So AWS at the top level, I have 24 geographical regions, right? Each region is a set of availability zone, right? Okay, so here is a map ratio that I like to see. So basically at the top, you see AWS Cloud is set of regions. Each region is set of availability zones. Each availability zone has 2 or more data centers. So get that clarity of regions, availability zones, and then you have the data center. Perfect. Let's move on here. One key thing is a availability zone is actually, think of it like a metropolitan area. right? So it may have multiple data centers at different locations, and they can be miles apart. They're not like next building. So you could pretty much design a DR and high available applications as a multi-AZ architecture. And by the end of this 40 minutes, you all will be master of all the AWS services. I know, I'm kidding. It's super, super hard. What I like to suggest to the customers is narrow down the list of services based on the application you're working, and just first get that going, right? There's no need to learn all the services. Before anything else, let me just make sure you guys are able to hear me. Okay, all is great, wonderful. Just wanted to make sure. So anything starts with shared responsibility model. What that means is there are two keywords, in and off. Security off the cloud is on us. Like, think of it like the hypervisor down to the data center, power, cooling, everything is on us. But anything you bring in to the cloud, it's basically your responsibility. We give you tools. So let's say you bring in data to give you, we give you tools to encrypt, decrypt, right? You want to have identity, we give you ability to do federation, OAuth, SAML. So we give you those tool sets, right? Key management, we have a service for the same. But always have this, anything you bring in, that's yours. Anything off the cloud is ours. It's a shared responsibility model. And we give several set of services in the security across different pillars of the application. Okay, I am running through quick just to get people accustomed to AWS if they're not familiar. We have a big AI ML stack. Just to when you modernize your application, you may look for use cases where you can add leverage these services. We have a very detailed data analytics platform. Again, end-to-end ETL, extract, transform, load. You may want to use some kind of data warehouse, do a BI visualization using QuickSight. So we have that end-to-end data analytics services also. And on top of AWS services, we have partners. So all the partners are building on top of AWS and enhancing AWS. Okay, so now let's come to the actual topic. Overview of .NET on AWS. You may ask, like, did we start supporting .NET today, yesterday, right? So here is a journey last 12 plus years that we've been on. If you see early 2008, we started with Windows and SQL Server, supported different editions of it, right? 3 to 8 to 12 to 16 to 19, and then moved on to supporting SQL Server, again, different set of editions. Then moved on to supporting .NET and .NET Legacy, .NET Framework, as well as .NET Core, and now .NET 5 across our compute services. And then identity, integrating with Active Directory, tracing, integrating with X-Ray, giving you the CLI, PowerShell native experience for .NET-based manipulations. And we are proud to say that we were the first cloud to be .NET 5 ready. Okay. So what are the tool sets that a typical .NET developer would want, right? Most of the .NET developers are very familiar with Visual Studio. So first, they would want to work inside Visual Studio. Or Visual Studio Code, we have support for Visual Studio Code, and JetBrains Writer. They may want SDK. So there are so many services, Amit. How do you manipulate those services? So basically, do you have an SDK? That's the question that I get asked, right? Somebody mentioned CDK in the previous session. Yes. Do we have a CDK for .NET? Right? And instead of talking all this, you know what? Let's stop the PowerPoint and go to my demo. So let's go in. Okay. Can somebody confirm they can see the screen? Are you guys able to see the screen? Thank you, sir. Thanks a lot. Okay, so here is an example of the Visual Studio IDE where I have installed something called AWS Toolkit. So let me go ahead and show you what I'm meaning. Here you go. This is the toolkit. We have it for 2017, 19, and also the previous editions of Visual Studio, right? Once you install the toolkit, you will notice a very neat utility called AWS Explorer. So AWS Explorer, basically you want to see all your AWS services right inside Visual Studio, right? I can see all my buckets inside Visual Studio. If I want to create a new bucket, I can create it. So the idea is a .NET developer, hey, you're focusing on building something. You don't want to hop different places. I mean, usually what happens is people work inside the console, right? This is where you work. I may go to the S3 bucket. Let's just go quickly and see it. And I can see my list of buckets available here. Okay, hopefully things work here quickly. Okay, here you go. The same set of buckets that I saw there, the same set of buckets are available here, right? So the idea is .NET developer working inside Visual Studio, we want you to get that experience to manipulate the services right inside Visual Studio. You may say, Amit, how is it connected, right? As you at the top, you see something called profile. So you can specify a profile. Here you go. And you specify the access key and secret access key. Once you can specify that, it automatically connects. You can have multiple profiles so that if a developer is working on different set of accounts, you can have different profiles and you will connect to that particular profile. I'm assuming folks are aware of the IAM services. But just to quickly show you, in case folks are new here, I quickly go in there and I can go to users. I can say, hey, I want to add a new user. Okay, Meetup. Let's just do it. And I will give it access as programmatic access. Okay, permissions, like what permissions this user will have. I can copy it from existing users. I can attach policies. So just for the sake of this demo, I'm gonna choose existing one. And this will define what services, what actions can this particular user do. Once it is created, you will see it actually gives me that information, the access key and secret access key, right? And that's what I use to connect. So we got connected, and then you will say, okay, I got the Visual Studio part. What else do you give? What does the toolkit provide additionally? So if I go to File, New Project, and I can actually choose the platform here. And once I narrow it down to the platform AWS, I can see the starter project templates. So boilerplate codes auto-generated for you. So that helps you with it. What else can we do? I mean, I am inside Visual Studio. What else can I do? So I'll show you a quick website. This is a typical ASP.NET application I created. This is using D3.js, basically visualizations on the client side using JavaScript. So let me quickly see. Hopefully the demo gods are happy. Here you go. So it just shows you the list of cities and the ticket sales in that particular city. Here you go. Right? I can sort them, filter them. This is completely on the client side. Right? I can choose one of it. Again, client side. I can choose different cities. It filters it. So they are all cross-linked. Right? And the same application I actually published. If I go here, stop it. I can right-click and I can get publish to Elastic Beanstalk right from Visual Studio. So basically, for a developer to quickly test how things are working, this is a pretty neat integration for deployment. We integrate with Beanstalk, container services, as well as Lambda. So because for this demo, I already published, so I'm going to go inside the console. No zoom. Let's go in. And I open the Beanstalk. Okay. Beanstalk is our like a near past like service. So to get started, this is a pretty neat service for web applications and web services. It gives you out of the box health monitoring. It gives you out of the box ability to see all your logs, health, right? So you can track what's happening request wise. It's pretty neat. To get started for web applications and web services, highly recommend using leveraging Elastic Beanstalk. Some customers may need to go to EC2. I mean, in case you need to have more customizations on the underlying environment, but Beanstalk gets you going pretty fast. Okay, so what else? Let's see the SDK part. So we have SDK. In this case, let me quickly show you a demo of manipulating the same S3 service. Before I do that, I want to show you the Nougat packages that we have. So AWS SDK. And as you can see, for each service, there is a corresponding Nougat package. So think of it like any application you're working, and if you have to manipulate some AWS service, you would go corresponding, take the dependency on the Nougat package for that service. So in this example, what I have done is I have taken dependency on S3. So let's see the S3 code. What am I doing here? Very quick, using the pattern is amazon.s3, amazon.s3.model. So if you see the pattern, it's amazon.servicename, amazon.servicename.model. So that's a typical pattern. Any service, you can just replace it with that way. EC2, amazon.ec2, amazon.ec2.model, right? So that's how the typical pattern works. You create the client of that service, and then you call. So let's quickly go and do a debugging session with this, right? So go in. It's using the current credentials based on the profile. So whichever is the profile selected, it is using that credentials from that profile. So I create the client, S3 client object. And what would you expect in a simple S3 client, right? It's a scalable object storage. So you will see like copy, move, delete. It's a storage, right? So, and it does show you sync async. So you can call things synchronously, like call and wait, or you can call it asynchronously. So you have a callable IAsync result, and there the callback would come, right? So the both are available. So let's go in, and then I go into the list bucket. So this is one of the function that I'm calling. So basically iterating through the buckets, right? So you have a typed object. Once you get the typed object, you get properties of it, and you iterate through it. So the same thing that we saw, I see the list of buckets here, right? Just to repeat, what I did is basically took the Nougat dependency and imported the corresponding service, amazon.servicename, amazon.servicename.model, created the client of it, and then you have list of calls. Let's take another example. And in this case, I will use a very different service. We have a service called Comprehend. So a Comprehend service, by the way, one quick thing I want to show you. When you call S3, how did it actually do the authorization? So I have a Fiddler installed just to show you the API call that goes to the AWS environment. Let's quickly go in, open this, and I am going to run this example again, just to show you that call, how the API call was made to the AWS environment. Okay, so the Fiddler is opened. Okay, hopefully all the demo gods are happy still, right? And what's a demo if it doesn't fail? So if it fails, it fails. Let's go in and call again. Okay, so let's get in. Thank you, listing bucket. This is the place where I'm calling it. So I called it and it came back. So now I should have seen that call. Here you go. That S3 call was made. Eesh. Okay. Okay, stop it. Let's go in and show you the S3 call. Here you go. If you see, S3 service returns an XML. So SDK does many things. One of it is like the serialization aspect of what goes input and what is returned back. It's abstracted from you. Some of the services may need JSON. Some of the services work with XML. The older ones are XML based. Here, if you see authorization header that was passed, there is a HMAC signature. Remember access key, secret access key. I mean, access key, there is nothing secret, but secret key is definitely secret. So using the secret key, it generates the HMAC signature, and that is passed as an authorization header to the API. Okay, hopefully that makes sense. And I will show you another example of the SDK now. So stop the demo here. I go to the Comprehend service. So Comprehend is our AI service, one of the AI service, where given a text, it can find out sentiments. So it can find out entities, key phrases, what sentiment it has. So here is one text, which is very, very simple, and there are reviews, and it just says some of the places I visited. There are some of the suggestions are terrible, so there is a sentiment. Let's quickly go in and debug this. So what is the program? Comprehend. Remember the drill? Dependency package. So in this case, what package? I got comprehend. And at the top, I got using amazon.comprehend, amazon.comprehend.model, right? Create the client, call the functions. So that's a typical drill. So let's go ahead and run this. Okay, hopefully the demo gods are happy. I'll just say without you again, hopefully that makes it more happy. So here you go. I'm calling the domain language, entities, and each function I'm using a wait so that it uses the underlying thread pool. And then the output, I am putting it onto the file. So let's continue. And if you see the output, here is the file generated. And as you can see, it was able to detect language as EN. So this is the language, right? It was able to detect entities, 2021 date. It was able to identify key phrases. And then finally, the most important thing, it was able to detect sentiment also, right? So that's another example of using another AWS service in your .NET application. Similarly, recognition, same thing. Recognition.model. Recognition gives you ability to take an image, find out attributes from it, right? So faces or attributes, you can call that. In this case, I'm calling faces. Similarly, there are other sets of services. Hopefully that give you a good run through of Toolkit and SDK. Those two things. Toolkit gets you Explorer, the most important thing, so that you can see all your resources. Not just see, by the way, you can do things also here. So I can do a launch instance. I can select an instance, and I can actually connect to it, right? So it's not like a dumb. There is good amount of I can stop, start, good amount of functionality exposed right inside Visual Studio. Okay, you saw the starter templates. You saw the publishing, right? We get ability to publish right from Visual Studio. Here you go. I can show you again. Here you go. Publish, right? So those are some of the beauty of it. So let's go back to our slide deck. So we saw Visual Studio. Similarly, we have Toolkit for Visual Studio Code as well as JetBrains Rider. One key distinction is Visual Studio Code and JetBrains Rider has more serverless oriented features. Okay, so SDK, we have it for .NET as well as .NET Core. We have a CDK. So if I don't like templating. I don't want to write CloudFormation templates, right? So I would rather write C# code. So I can use CDK for .NET and generate those CloudFormation templates. We have integration with CLI. The right-click publish that you saw, we also have a .NET CLI equivalent of the same. So many customers, what they do is they actually call the .NET CLI extension in their CI/CD pipeline. Okay. We also integrate with Azure DevOps. We also integrate with many other CI/CD services and partners out there. Okay, so we saw the demo. So quickly running through, you saw the Explorer. You saw getting started templates. You saw the easy deployments, right-click publish, right? Here are the same things in a screenshot fashion. We have Toolkit for Visual Studio Code, for Writer, Programmatic XDK. One key thing on SDK is a consistent coding pattern. You would see complete consistent coding pattern. As you can see, using service name.model, create the service client, and then do the operation. So each operation may have a request information that it needs, and then it'll respond. So this is consistent. You manipulate one service, you pretty much manipulate all other services. So that's the learning curve is much faster. Yes, the learning is underlying functions, underlying functionalities, underlying methods, what are exposed. That takes some time to understand. The same thing that I showed you demo, in this case, it's calling the S3 client and calling the list object async fashion. Okay, we saw that. We also have the command line, as I said, .NET CLI templates. So you can do create projects, deployment, and integrate inside your CI/CD pipeline. So that was .NET tools. Now let's go across app modernization, right? When I say app modernization, it could be moving across different abstraction tier. So basically, maybe you are first hosting it in VMs, virtual machines, and then slowly you are modernizing the same application to target containers or serverless based, right? So what are the ways in which you go there? We will discuss that. Leveraging and managing cloud-based services wherever applicable. Leveraging, enriching your, like if you have a legacy application, you can enhance that legacy application by adding newer use cases. I just showed you an example of using Comprehend. You could use another AWS AI service. Like some customers I have seen, some use chatbot and enable actually chatbots inside their applications, right? So integrating voice interfaces. So the modernization could mean many things, but at the bottom, it's the abstraction tier. This is a typical modernization journey of customers. Think of it like an on-prem customer who has web servers, API servers, data tiers. They first get it onto AWS, and here is so what we were here, we moved to here. So we got pretty much EC2 based architecture. I don't think this is where you want to stop. Maybe you can start here, but you want to continuously modernize yourself. And my rule of thumb is the lesser the operation, the more the focus on innovation. So I would want to go the higher abstraction tier, which is the serverless stack. So let's get rid of that, get the serverless stack as much as possible. In this case, I replaced the API tier with API Gateway and Lambda. And I decoupled. So many existing applications were written in a synchronous fashion. You want to just decouple that. Caller gets a response that, hey, we got it. And then once their actual background processing finishes, it notifies that, hey, we did it. So decoupled based architecture are way better, right? For .NET applications, here are the list of services where you can deploy them. So .NET framework based is EC2, Beanstalk. I showed you a quick demo, which is more PaaS-like, Lightsail, a container service, and Kubernetes, container service or Kubernetes. For .NET Core or .NET 5, pretty much across. Changing from .NET Framework to .NET Core will enable you target Fargate, which is serverless containers, and Lambda, serverless functions. So that's how, and this is basically the key here. Level of abstraction and amount of work. Here, I have to manage the underlying VM. I have to manage the patching, updates, and all that. Here, all I have to do is give the function. So you can see the difference between the amount of operations work that you will have to do, right? We actually have a new blueprints published. So let me quickly show you that. So if I open up a new Visual Studio and create a new Lambda function, we recently integrated with .NET 5, and now Lambda actually has I want to create a new project. It's the container support with Lambda, and we have boilerplate templates available for the same too. So here is the Lambda. Okay, so I'm gonna go. Let's do a test. As you can see, here is the boilerplate functions. This is the .NET 5, so Lambda, but it has container image support. Let's generate something to show you like what that boilerplate code is. When I said it generates boilerplate codes. So this one is basically a Lambda function which takes an image, does a recognition call, finds out attributes, right, and updates that information. So once it generates, I can show you quick pieces of the code. Hopefully the demo gods are happy. It is working a little slow today. Okay, so here it got generated. And if I see the function, here is my Lambda function. As you can see, it uses S3, it uses recognition, right? And here is my actual function. Here you go, function handler. And it called the detect label async. Right? So it pretty much generated the whole code for you to get started, and you can customize it. Right from Visual Studio, it also gives you ability to deploy. So publish to AWS Lambda. It'll take care of deploying too. Right? Go in. So that's the boilerplate toolkit. We have AMI, the Amazon machine image for .NET 5 too. So how do you modernize? Like, what are the tool sets that we provide you? We have many tool sets. I'll quickly highlight some of those. App to container. So if you have a legacy websites, like think of it like ASP.NET web forms, ASP.NET MVC websites inside IIS, and you want to containerize them, app to container is your friend. It can run the app to container on that IIS box. It will auto analyze the list of websites, and it will give you ability to containerize them. And not only ability, you can actually use it to publish it on AWS, right? Porting assistant for .NET, very neat tool if you have legacy .NET framework based application and you want to analyze what it would take to port it to .NET Core, .NET 5, right? So it can give you information about what Nougat packages dependencies you have, what is the incompatibility, actual source code that you would need to change. We have a couple of additional services in this space to actually enable end-to-end portfolio assessment and doing guided modernization decisions. This is drift service, decomposing existing monolithic based application into set of microservices. Those are work in progress. .NET Core is where pretty much all the actions are happening, and Microsoft itself is doing .NET Core, .NET 5, but .NET Framework is still supported, so both have a place. Using Porting Assistant, you can do analysis of the application. It gives you dependency mapping. And trust me, many of the customers I've gone through, some customers don't even know their own solution, like what is dependent on what. So running Porting Assistant actually will help you understand your application details. Right here, you can see it can show you compatibility, incompatible reports too. Right. App to container, again, run it on your IaaS boxes. It will auto crawl, find out all the websites, and give you a ability to deploy them on AWS ACS containers. This is one rudimentary flowchart analysis, like how we start discussions. There are three typical patterns: rehost, replatform, refactor. I mean, there are other like repurchase, retire, relocate. There are different set of Rs, but at the top layer, rehost, replatform, and refactor. Typically, we start with like hosting, in that case, EC2 and Beanstalk. Replatforming, usually you target containers. If it is a .NET Framework-based application, then it's Windows containers. And if it is .NET Core, then you have Linux containers. Refactoring, if it is targeting .NET Core, .NET 5, then you go towards Lambda, step functions, and others, right? When you are modernizing the application, it's not just about taking the existing application and mapping it to the right compute services. It is also about, can you change the existing application? Maybe you are using a session state. You can target Redis Elasticache for the same. Very simple, like using configuration. We have many providers. So all you do is in your session state, you specify the Redis session state provider. You don't have to change any code. That's one example of it, right? Okay, so that's modernization for you. Along with that comes the tracing. So you can use AWS XA for tracing, and this is very useful if you have application that is known for some trouble, like performance issues. You don't know where the time is being spent in a thread. Like let's say if you have a web tier, service tier, another service tier, and data tier, and how the request flows. XA can help you. It creates something called correlation ID. And using the correlation ID, you'll be able to actually map and narrow down to how much time is being spent in each layer. Very, very useful. It can track all the HTTP calls to the web APIs, AWS services, and give you the report, right? Here is a service map of it. It captures, stores it in AWS. You can see the service map to understand more. You can drill down, dive deep. You can actually annotate piece of a set of code, and so it is a separate segment in itself also. Another utility, application insights for .NET and SQL Server. I mean, obviously, once you have productionized it, you want to know how actually I can see what's happening in my applications, right? There are so many application components. You can get this dashboard insights and create alarms that will notify you, right? Very useful app insights. So next is development environment. I mean, we discussed Visual Studio, but does AWS have only Visual Studio? No, we have it for IntelliJ, PyCharm, Eclipse, VSTS, and we have many other languages supported for other than .NET too, right? But we have our own code suite services, code build, code commit, code deploy, code pipeline. One beauty of it is like you don't have to use AWS code suite service. You can plug and play. Like you can keep your source code in GitHub. You can use Jenkins as a build server. You can use a code pipeline to do orchestration. Let me quickly show you what I mean here. So I go here. Let's go into code pipeline. Okay. Okay, I can see the pipeline. And these are different stages, right? So, hey, get me the code from GitHub, do the build, do the deploy. You can always modify and add new stages. Like some FinServes, they say, Amit, we just need to make sure something manually. So I call that as a make sure stage, just for the sake of it, right? And you can add action groups in make sure stage, right? Make sure action. And there are different action providers. This list is limited, but it can grow. As you can see, manual approver, code build, Jenkins, and many others are available here. So you can add those different actions. And pipeline is the one that does the whole orchestration. Get the code, do the build, run the test, do the deployment, right? You don't have to use all AWS services. You can integrate with your CI/CD pipeline too. Okay. So we pretty much integrate with most of the well-known CI/CD partners. Machine learning, we discussed. You can always enhance your, so there are 3 layers here. At the top layer is where the .NET developers are more interested, because give me a pre-trained model and tell me the API that I can call, right? So that's perfect for AI. I showed you ability to call comprehend. You can see and leverage your in your applications. Here is an example of translate client. Again, the drill is same. Translate.model, create the client, put the input, get the response, right? So that was my run through of quick .NET on AWS. And this is some good resources. You definitely want to bookmark aws.amazon.com/net, because that's our homepage. You want to connect with us on Twitter. You want to look at the white papers that we publish, and that should get you started. Happy to take questions, if any.
Thank you. Thank you. Thank you for this presentation. We got plenty of questions, actually. So let's start from, you deployed an application like BI dashboards for Redshift. Is it better to use AWS QuickSight for dashboards instead of developing a custom application?
Very, very good point. And not just QuickSight. There is Tableau. There are other set of visualization softwares out there. I'm a developer, and I like to explore different engines. And this was a new engine, the JavaScript engine. And D3 has a good visualization capabilities that you could do on the client side. Hence, I used it. You do not have to. I mean, obviously, you can embed a QuickSight dashboard inside your .NET application, right? That's a perfect use case. I don't want to come across like a sales guy who's putting all AWS services. I like to explore different components. So definitely explore QuickSights and integrate them. It has a pretty neat spicing engine, and it can do good amount of BI capabilities.
Great. Thank you. Thanks. The other question is how often AWS updates AI algorithms for comprehend recognition? What is better, use predefined AWS AI services or create own, like models with SageMaker?
That's a very good question. So as I said, when I was showing the ML slide, there are 3 types of AI ML developers. One is basically who wants to have complete control to underlying infrastructure. They may want to create their own model, run it, and train it against different set of data. Right, so that's fair, and we have services for them too. SageMaker is Studio is getting a lot of traction by using Jupyter notebooks. We have support for all the ML platforms out there. I used the AI services. Basically, typically the .NET developer I meet, the enterprise .NET developer, they have ton of work on the enterprise side, so they don't get the time to actually do that whole build, train, model, like a different set of data. Now, the frequency with which the changes happen in comprehend recognition, I think if you connect to AWS What's New, usually you get to know what's changing. You won't believe, like, my homepage on the browser is AWS What's New, because I don't know what changed last night, and the speed with which things happen here, it's really hard to be on top of it. So at this moment, I really don't know what's the frequency with which it's being updated, but I can take that look at it and come back with a response.
I can imagine that with such speed of new features developed, it's quite hard to be developer advocate.
Yeah, you got it. I mean, I now feel like I say, I don't know what I don't know. So I am not the person who knows everything. Give me your use case and I can help you. And I also learn along with you because I learn a lot while doing these sessions.
Great, thank you. There is one question which is quite wide, but if you can share some materials, and this question is, can you share the best practices of making application for AWS using .NET? Is it any resource or something?
Oh, that's actually a very good question. We do have something called well-architected principles, and we have white paper on well-architected. It's kind of generic, .NET oriented, but actually a lot of the it is basically a set of best practices across 5 different pillars: resiliency, security, operations, availability, and you can actually read through those guidelines, and you can actually incorporate them into your .NET based applications. But I take that feedback. I think I'll probably see if we can have a specific .NET oriented, well architected guidelines. So for now, I start with that. Join our Twitter and our Twitter handle, and be on top of it. Like, we are responding in forums also, so feel free. And if you have AWS account team working with you, give the feedback to your solutions architect, account manager, technical account manager, and that goes into a product feature request. We gather those and we drive the service team to improve it.
Great, thank you. There's an interesting question. Amit, what is your favorite AWS service? Maybe some secret tool you enjoyed using the most of the solved a tech business problem magically?
Yeah, it's a good one. That's another good one. I love config. I know some people may not like that much. It's operations used more. Config and config rules. Now I'll tell you why I love it. Because in databases, there is something called triggers, right? Where you can actually hook into, and DML operations, you can actually capture and say, yes, no, you want to have it or not. Similarly, every AWS resource, the change of it gets captured via config. So there is a config item that gets created, and any change, there's a new version of config item. You can actually write config rules against it and allow deny it. I'll give you a use case. Let's say an enterprise decides that all developers, thou shall not be able to create R4 8x large some EC2 instance. You can actually code that, because it's basically on EC2 instance create ECO config rules that gets called, checks whether the current person has the permission to do that, and does not allow it. So basically, you can do proactive governance, do proactive cost, do a lot of different use cases, enable that, because you are right there when the change is happening. You can do what you want, and you have the context of what the change is. So config and config rules are very, very useful services to me.
Great. Oh yeah, AWS is very rich on configuration. That's true. So the question about your slides. Are all services from the slides for .NET Core available in all regions, or they got some limited availability?
So there is information on it, like for each services. Like, mostly we try to keep in sync, but obviously for newer services, there are some regions where we get them, learn from it, and then slowly get them into a different set of regions. But if you have a specific service and a specific region that you would want, reach out. I would be happy to take that to service team and get back to you on the timeline for it, if in case it's not available there.
Oh, thanks. Appreciating your help here. And the interesting question, why it is called Amazon Recognition with letter K and not Amazon Recognition as it should be, grammatically?
That's again a good question, man. There's a little bit of peculiarity at AWS. Like when I joined, it's like Route 53 versus DNS. There are like different lingos. Maybe it's part of it. Maybe the naming team has some rules. So I really don't know what was the underlying reason why they put that.
And I actually really like this recognition through the K because, it catches attention.
Yeah.
Okay, and my favorite question for folks from Amazon. Like, what do you think the key benefits of AWS Lambdas versus Azure Functions?
Oh, that's a good one. I mean, what I will do is I'll try to be on Lambda and not make it like a compete kind of discussion. And it all depends on use case. Maybe Azure Function is right for your use case. I don't say that that's wrong. So I say I love Lambda because one, I don't have to do any operations. That's one of the big advantage. Second, when I started learning in EC2, I had to learn auto scaling policies, launch configurations, right, alarming, and CloudWatch. There's like a little bit of like networking, subnet groups, and security groups. And as a developer, like give me the endpoint. I want to call that endpoint, right? That's what I like. So Lambda makes me enables that to me. I should say that. I mean, EC2 has its own place, container has its own place, and serverless has its own place. Like if you have an application that gets 24/7 request, in that case, I mean, Lambda can get costly, right? So you want to do your analysis in terms of really, you may have application that's running long, right? And Lambda is basically meant for short, quick calls, call and come back kind of use case. So containers have its own place. EC2 has its own place. If you get a legacy, and I come across many customers like, oh, I need to deploy this custom tool, manipulate this registry, and all kinds of things. I mean, go EC2. I mean, that's where you can do all that. Lambda does not give you access to the underlying. It's actually underlying Linux cluster, right? It does not give you access to that. You don't have any access to the same. So if you are willing to forego that right, and if you are willing to just focus on your application, build your application as microservices, because I mean, smaller microservices based set of applications are more scalable, innovate faster, right? I mean, it enables that. So let's say API Gateway or MuleSoft or Apigee, whatever is your front service tier, the backend is Lambda. Some customers, they start with EC2 as backend and slowly modernize towards container and slowly move towards serverless. So it's kind of a journey that you have to take and appreciate. Any new development, I would any day prefer serverless stack. And with Lambda, with containers image support, it defeats the argument of like, hey, I'm getting logged in and that kind of thing, right? I mean, there's nothing, you can always move the containers anywhere. And even in the previous editions of Lambda, some people, what they did was they actually implemented Lambda function as a wrapper to their libraries. So their libraries were separate, right? So you still get portability of it. So it's a win-win for net new development. Microservices oriented architecture supports it. Lot of underpinning, or we call it undifferentiated heavy lifting work, I don't have to do. Hopefully that convinces.
Yeah, that's answer. So, Amit, we have actually a small prize for the question which was your favorite. So, what question you liked most of all?
What's my coolest service? What is the coolest service that I like? I mean, that's the first one I got asked.
Great. So the person who asked the question about the coolest service, please contact with the organizers. They will send you the bonus. Thank you, Amit, for your presentation. That was awesome. Thank you.
Thank you. Thanks, DIMA. Thanks the whole team. You guys have helped me with this. This was a new experiment, so I learned a lot. Look forward to doing more of these. Thank you. Have a good day.
Thank you. That's the goal of our user group, to learn something new every day. So, спасибі велике вам, що були сьогодні з нами, були активними і ставили досить багато запитань. Я, чесно кажучи, навіть здивований, тому що, зазвичай не так багато запитань ставлять. Прямо зараз в чаті і завтра в розсилці ми прикріпимо фідбек-форму. Будь ласка, заповніть її, це допоможе нам зробити кращий, більш крутіший формат мітапів саме для вас. У листі також буде доступ до матеріалів нашої сьогоднішньої зустрічі і також міні-джобборд від компанії Enix. І прямо зараз підписуйтесь на наші соцмережі meetup.com, Facebook, групу і Twitter. Спасибі вам і гарного завершення вашого дня. До побачення!